Good news. We're not going to take too long here with the notes today, but we still got more stuff tomorrow. SAC 2 still stands as next Monday, and you will get practice SAC 2 today as well. Five, I think five. I think it's 6.6. All right. The last graph that we did last week, haven't given you the notes yet. Some of you I have. Do you remember what graph we did, the very last one? Anyone? Anyone? What graph did we do last? Like exponential? Not quite. The hyperbola. Okay. So today, this is the truncus today. But remember, the hyperbola, just as a recap and just to refresh your memory. Sorry about the scrolling. Kind of looks like an X. That's not quite complete. How many asymptotes we've got in this one? We've got two. Don't forget the one can hide itself in the axis. And this can also flip. So our normal one goes like that. This is a flipped version. I hope I've got that right. It's a flipped version because there's a negative. There is the example that we did. Flips the lines around with the negative in the front. Okay, so today we're going to look at the truncus. And I guess they call it the truncus because it looks like a tree trunk when you graph it out. We are following this equation here, y equals 1 on x squared. X equals 0. If you punch in x equals 0 in here, Amy, what happens? Undefined. Good. You cannot have a 1 on 0 squared. Cannot do. You say undefined, which is a nice mathematical way to say it can't work. But then something that's undefined graphically looks like what? Infinity. Not quite. Not quite. Good try. Good try. When you can't calculate something, what does it look like on a graph? It never hits the line. But what's that line? What's that type of line called? For this one, yes. But in general, we call it an asymptote. Whenever something you can't calculate, mathematically, graphically, it looks like an asymptote as a line that you can't touch, as people have been showing. Okay, just look carefully here. If x equals -1, 1 on -1 squared, what's that? It's going to be 1. Remember, be careful, get in a good practice, bracketing your negative, because that means two negatives make a positive 1 on 1, which is a 1. Okay, so 1 on 2 squared is 1 on 4. What's 1 on -2 squared? 1 on 4. 1 on 4 again. Okay, so 1 on half. How many halves are in 1? 2. 2. Thank you, Zaid. And remember, I made a blue already. We've got to square that.
So 4.
So that's 4. So let's just take a step back. Gabe's got the answer. 1, 1 is 1. 2 squared is 4. How many quarters are in 1? And as Gabe said, there's 4. Likewise, you'll get the same answer for a negative half version as well. So let's graph this now. You don't do this when you do the SAC and you're asked to do the Truncus. Do not do this working out. This is just for you to know where it's coming from. That takes a lot of time. We'll do one example quickly together where you can just get straight into it. 0, x equals 0 is our asymptote. X equals 0, one going there. Label your asymptotes.
So in the SAC, we only have to acknowledge asymptote.
Yes, and some points that it runs through. Some points, not all points. Okay. Okay, so -1 is a 1. 5. Let's go here. 1, 2. 1. -1 is a 1. 2 is a quarter. 2 doesn't go up to 1, it's a quarter, which is about here. -2 is a quarter. -2 down here. Okay, I didn't substitute in my 1 there, but we know that that's going to be here. If I go closer to 0, I have fractions that can fit in more. So a half gives us a 4. Half jumps up to 4. On the other side, a negative half jumps up to 4. And you'll see a tree trunk appearing. Okay, tree trunk appears. We've got one asymptote here. What's the other asymptote?
Line 0.
Yes, you're both right. Long y equals 0. Okay. You can see that it can't be, you can never get negative values in here. Notice all these values, no matter which way you go, x positives or x negatives, they're all jumping up above the ground because they want to grow and reach the sunlight. It's a tree. Okay. Okay. Important to water your plants. Any questions with that? So no matter what you do, it goes positive. Okay, let's just do one Truncus example together. This is the one we've done so far. Okay, so this one here. What do I know that's the Truncus? I heard it. Sorry, Jesse? No. There's a square in the denominator, gives us a Truncus. Thank you, Zach. Yeah. This is our normal Truncus equation, our basic Truncus equation. It's the starting point of any Truncus. If there is nothing out here, there is actually something. When there's nothing, there's something. And that something is a 0, which is related to this level here, on ground 0. You've heard of the word ground 0? Okay. You're too young for September 11, aren't you guys? September 11th. What year were you guys born? Wow, 7 years after September 11th. Okay. Ground 0. All right. Let's have a look at this one here. If I were to graph this, just by looking at what I just shared to you, what is one of the asymptotes?
-1.
It's -1.
Y equals -1.
Y equals -1. Thank you. So we go -1.
Yeah.
Asymptote straight away. Looking at the graph as well, a -2. Okay? Yep. Punch in -2. Okay. Now, look carefully. We have a tree trunk happening here. But how's this tree trunk going to grow based on these asymptotes here? What are we looking for? What direction is this tree growing? Okay,
Down.
it's going down.
So it's
Okay.
negative.
Because we're flipping all our negative, we're flipping all our values down to the negatives. So you have a tree trunk in here, but this negative is going to flip all our values down to the negative section. So if you have a +2 up here, this negative will bring it down to a -2. An upside down tree. Okay. So now we know that our tree trunk is going to go downwards like this. You can't just do random things here and there. You need actual values. Okay. So in this case here, like any graph first, what sort of things are we looking for in a graph? And Rita, what's one thing that you normally work out? An x-intercept. An x-intercept where y equals 0. Okay, let's do the work here. So we're going to change this now.
It's not the one.
I heard it.
There's no.
There is no intercept here. But it's always safe to work it out mathematically so that it becomes undefined mathematically. Okay, so let's just play dumb for a bit. You're not dumb. Let's just play. What are we going to do?
One.
Move over the 1. What are we going to do now?
Times 3. That.
Times 3 that thing. Okay, what are we going to do now? Okay. We won't open. We're going to leave it closed. We're going to bring this over a -3. We don't want to open, it's like a Pandora's box. We don't want to open something that we're not going to be able to close back in. So we want to keep it nice and neat. Keep it as a bracket. But if I've got a square here, okay, if I've got a square here, what's the opposite of a square? The square root. Okay, so we're going to reverse that and do that. I hope that's mathematically right. If I'm wrong,
Yeah.
yeah. If I'm wrong, I'm wrong. We'll see how we go.
Because
This is going on YouTube, by the way.
yeah, because square root of 1 is.
Yeah. So we're unraveling the square. There's a square root on the other side, but square root of a -3.
Just leave it's 0.
It's not 0. It's undefined. And then, only then, do you say no intercept. No intercept. Okay? You have to, don't just say there's no intercept there. You have to show me that there is no intercept there. Okay. We've done x-intercept y equals 0. What can we do now, Perry? Find the y-intercept. Good. We're going to punch in 0. Pull my x 0 plus 2 squared minus 1. Three times 2 squared minus 1. Negative 1 on 3 times 4 minus 1. I hope I'm doing this right. Negative 1 on 12 minus 1. Okay. Negative 1 on 12 minus 1 is?
Negative.
Negative 1 on 1. You just put them together. Okay. So over here, as that, if you get that as well, that's also correct. Okay. So when we go over here, x equals 0, x equals 0, I want it y, I want the intercept at y equals negative 1 and a 12. So negative 1 and a 12 is here. Negative 1 and a 12 is about somewhere there. And you must label, or you will lose your marks. Okay. Any questions with that? So what you can do from here, our truncus, because it's a negative, is roughly going to go like that. And then on the other side, symmetrically, it is still a sketch. You do mark it down like so.
How does the 3 change it?
Okay, a 3 is a dilation. Notice with my normal truncus is a nice, healthy tree. It's a healthy tree. Okay. This in front here is, what do we normally call the number in front? Starts with the D. It's a dilation. So whatever that number is front is going to affect the stretch. Sometimes you're going to get a skinny tree. Okay. Sometimes those big fat trees, big trunks, nice and wide. That dilation factor will do that. So
Would you get a wide tree when like the dilation is half or something?
we can let's try that out.
Like when does it start getting wider than normal?
Yeah.
Like, can we just below that?
Okay. Yeah. Okay. We'll just go to this one here. Test it out. Say, I don't want to say it and get it wrong.
I assume
Okay.
it's like with gravelers, the greater the
Yes.
dilation, the thinner it is. So.
Yeah. So I know for what Gabe is saying, a normal x squared, this is y equals x squared.
Yeah.
But if I put a 10 in front of that, I'm going to make all the values jump up by 10. So I'm stretching them up like a rubber band.
So it's gonna get thinner.
So it gets thinner.
So if you put half in front of x, it like squishes down.
And it squishes. So it squishes down. We halve all our values. Flatten. It goes like that.
So the tree would probably get thicker.
I'm not 100% sure because we've got the dilation as a denominator.
It doesn't have to worry about this.
No, you don't. But you will need next year.
But if we like, it says like translated or dilate, we have to say dilate 3 times.
Yeah. Most of that is actually done with cubics.
Okay.
And
So we're not doing that.
I hardly ever see any dilation questions based on Truncus. It's mainly
Just parabolas.
parabolas and cubics. Okay, but I'll double check that in case I'm wrong, but I haven't seen it lately. Okay. You may, yeah. Okay. Any questions with that? All right.
Yeah, so if you have like a 0.5 dilation, it's thicker.
It's thicker with on the bottom.
What?
Are we talking about Truncus's? Okay.